The internet makes it possible for one computer in one place to talk to another computer in a completely different place. But it hasn't always been this way. In the mid-1970s and early 1980s, the set of protocols that enables computers to talk to each other was being developed. The sending and receiving of data on the internet was made possible by two protocols, TCP and IP. TCP is the Transmission Control Protocol, and it splits data up into packets and puts them back together again at their destination. IP, the Internet Protocol, tells the packets where to go and to where they should return. Let's see what this looks like. The things you get from the internet, like an HTML page or YouTube video, and the things you send over the internet, like an email to a friend, are all data. In order for data to be sent over the internet, it needs to be broken into packets. A packet isn't an entire web page, or even usually a whole email. It's a small chunk of data, like a puzzle piece of the whole picture. By breaking data into these small, manageable chunks, many users can transmit data at the same time very quickly. In essence, these packets are a way of sharing access to the network, so that no single transmission dominates the pipeline. The TCP/IP protocol suite is responsible for creating packets, making sure they get where they need to go, and putting them back together again at their destination. If something gets lost along the way, TCP will request the packets to be resent. The directions on how to accomplish this are written in a header and wraps every TCP packet. Once TCP makes a packet and wraps it with a header, the packet is handed off to the next layer, which will handle the details of how to transmit the data. Now, every computer on the internet can be identified by its own unique number, called an IP address, and the IP protocol uses IP addresses to route the TCP packets. In order to transmit the data to the correct location, the IP protocol also adds a small header of information to the packet, just like TCP. The IP header contains information on how to send the packets, such as the source IP address and the destination IP address. Now, because packets often travel through a number of routers on their way to their final destination, to make this process really fast, each packet is designed to work independently. This means that each packet can travel from router to router in the fastest way possible to reach its destination. When all the packets are received, TCP will reassemble them, making sure they're all there and in the right order. Now that we understand a little bit more about how the TCP/IP protocols get data from one place to another, let's find out about the other pieces of hardware and software used to bridge the distance between computers.